Hi, hello everybody. Welcome back to our channel on answering one question a day. The question that we are going to see is on matrix vesicle theory, a very important concept of calcification. Calcification is defined as the process by which calcium are deposited in the organic matrix. It is deposited in the form of hydroxyapatite crystals, which is given by this form Ca10PO4 6OH twice. Very important. Ca10PO4 OH twice 0.10H2O because it is a hydrated form. The theories of mineralization includes Robinson's alkaline phosphatase theory, nucleation theory, which could be homogeneous or heterogeneous, and matrix vesicle theory, of which this is the most recent and advanced one. Always asked in exams. Okay, matrix vesicle, the answer should be like this: are small membrane bound structures lying free in the matrix where calcification occurs. The vesicle, that is in the extracellular matrix. These vesicles are rich in certain substances. What are the substances? Phospholipids and annexins. Phospholipids and annexins that gives the higher affinity for calcium to be secreted as hydroxyapatite crystals. Okay, the vesicle membranes of the vesicle contain annexins that forms a channel that attracts the phosphate and calcium within the matrix vesicles. So they attract the pyrophosphate, alkaline phosphatase under the influence. Matrix vesicle causes hydrolysis of organic phosphate to simple phosphate ion that binds with the calcium ions, forming apatite crystals that initiate mineralization, and these crystals are thrown outside the vesicles and grow rapidly, modulated by certain proteins, and rupture from the vesicles, which are released into the organic matrix, where they grow using the components of the tissue fluids. The factors that affects the mineralization we have to deal, but before that we'll see how it works. The organophosphatase is converted into inorganic phosphate ion in the presence of alkaline phosphatase. This together with NPT3 and annexins, or this phosphate ion is turned into calcium phosphate inside the matrix vesicles, which is turned into octocalcium phosphate, and that is turned into, in the presence of calcium and water, it is turned into hydroxyapatite, and this is the phase 1. And this happens within the matrix vesicle. When this hydroxyapatite are formed, they are thrown out of the vesicle by the action of phospholipase. And in the phase 2, newly formed hydroxyapatite crystals are modulated by osteocalcin, osteopontin to form complex hydroxyapatite crystals. At this stage also, calcium and phosphate, inorganic phosphates, are furthermore added. The proteins of like osteocalcin, osteopontin, and BSP1 contribute or help to this forming of hydroxyapatite crystals. Simply to say again, the mineralization takes place in two distinct processes. The first phase, the hypertrophic chondrocyte osteoblast or odontoblast, buds matrix vesicles where mineralization begins. They are membrane bound vesicles of about 50 to 200 nanometer diameter. Initial step of mineralization occurs within the matrix vesicles, in which Ca10PO4 6OH twice 10H2O crystals are formed. The phosphate, inorganic phosphate, is derived from membrane phospholipids, which are hydrolyzed by phospholipase C to produce phosphocholine and phosphoethanoalamine. These phosphor compounds are hydrolyzed by an enzyme called as phospho1, phosphoethanoamine, and phosphocholine phosphatase, that is within the matrix vesicle to yield inorganic phosphate. The calcium is incorporated into the matrix vesicle through annexins, calcium channels. So that is how the whole structure works. So these are high level if you are interested to learn, but not from exam point of view. Okay, now coming back to the factors affecting mineralization. The promoters of mineralization include alkaline phosphatase and nucleating substances. The inhibitors include magnesium ions, pyrophosphates, nucleotides, citrates that could slow down the process. Clinical significance: in absence of matrix vessels, calcification will not proceed further proper, like in rickets, osteomalacia, or enamel hypoplasia. Right? That is the clinical correlation. That is why we need to know matrix vesicle theory. Two phases, calcium hydroxyphosphatase. All this are the important points, and how you answer this diagram is more important. Exam point of view. Okay. Thank you for your patient listening. Stay connected with our channel to learn more and learn incrementally at least one question a day.